Hello again, here's page 6. Problem 34, we need the conjugate of this denominator. So we just change the sign in the middle. So it'll be 3 root k minus 5. And of course, we got to multiply the numerator by the same exact thing. Multiplying these denominators together, we can use the shortcut for multiplying conjugates, which says you square the first item. We're going to square 3 square root k. You square the second thing. We're going to square 5. And you put a subtract sign in the middle. So 3 root k times 3 root k. Let me slow that down for you a little bit. That's 3 root k times 3 root k. Can be thought of or rewritten as 3 times 3 times root k times root k. The 3 times 3 makes a 9. And the root k times the root k makes a root k squared, or just plain old k. So that's going to be 9k. 5 squared is 25. So it's 9k minus 25. Let me write that down over here. 9k minus 25. And for the numerator, we can either put 2 parentheses, 3 root k minus 5, or we can distribute the 2, do 2 times that minus 2 times that. Let me write it that way. 2 times 3 root k will be 6 root k, and then minus 2 times 5 is 10. There's nothing that goes evenly into 6 and 10 and 9 and 25, so that's fully cooked. Can't go any further. On to this little beast. Again, need the conjugate, so just change the sign in the middle. We will multiply the top and bottom by 5 square root h plus 2. 5 square root h plus 2. And if we shortcut that out, write it down this way again. So the square of 5 square root h, that'll be 25h minus 4. So it's 25h minus 4. See, no more radical sign in the denominator. That's our objective, to get a rationalized denominator. And then if we multiply this out, we're going to get negative 20 square root h minus 8. And this does not reduce. There's no number that goes into 20, 25, 4, and also 8. Okay, that takes care of that. Now 36, if you haven't said any bad words yet working on these, this could push you over the edge. Notice the indices are different, 4th root and 3rd root. So what we do, big picture here, is we resort to changing both expressions to fractional exponents, and then we try to get those exponents to share a common denominator. This is a bit of a chore. So what I'm going to do first is rewrite this. Instead of 4th root, I'm going to put the c to the 5th d squared in parentheses and say that's the same as exponent 1/4. And for the bottom, it's just cd in there. Cube root is the same as 1/3 power. Okay. Now I want to get these two fraction exponents to have a common denominator. 4 and 3/4 and thirds can be changed to 12ths. 1/4 is equal to 3/12, and 1/3 is equal to 4/12. So I'm going to rewrite this again down here. C to the 5th, d to the 2nd instead of to the 1/4, I'm going to write 3/12. And CD, instead of 1/3 power, I'm going to write 4/12. Okay. Maybe you want to pause here and take some deep breaths. Now, power of a power, we can multiply the powers. You get C to the 15/12, D to the 6/12. And I realize these fractions reduce, but you don't want to reduce them just yet. Trust me, you don't want to reduce them. Not yet. C to the 4/12, D to the 4/12. Now, old idea, one variable at a time. Where's the bigger power of the variable C? In the numerator, 15/12 is bigger than 4/12. So I'm going to go down here for space. We'll have the C term in the numerator, and the new exponent will be 15/12 minus 4/12, which is 11/12. We'll have C to the 11/12. What happens with the D? Bigger power of D is also in the numerator. We'll have D to the 6/12 minus 4/12 is 2/12. Okay, and now another leap of faith. I'm going to rewrite this. I'm sort of going to factor out the 1/12 again. I'm going to rewrite this C to the 11th, D to the 2nd. See, I used the numerators 11 and 2. And out here, I write the 1/12. Because remember, for the power of a power, we would multiply the powers, and 11 times 1/12 would make the 11/12, and 2 times 1/12 would make the 2/12. Now, we're getting close to the finish line. I can rewrite this 12th root of C to the 11th, D to the 2nd. And both powers are less than the index, so that's finished. Whew. That's exercise 36. You're very, very, very unlikely to see this on a midterm or even on a quiz, but we'll see one, I think, in Alex. No, there's a multiplication, but it's different indices again. That's square root and fourth root. So the first step is change over to rational or fraction exponents. So instead of square root, I'm going to write the power 1/2 instead of fourth root here. I'm going to write 1/4 exponent. And at the same time, I notice 8 is a power of 2. Probably it's going to be very useful if I change it to 2 to the 3rd. And we have x, y to the 7. Okay. Now, same as the previous, I want to get a common denominator for my fraction exponents. This one's a little easier in that I can change 1/2 to fourths very easily. I can change the 1/2 to 2/4. So let me write this again. Lots of writing. Instead of 1/2, I write 2/4. And over here I got 2 to the 3rd, x, y to the 7th, 1/4. Now everything in here is to the 2/4 power, so I'll write 2 to the 2/4, x to the 2/4, y to the 2/4. And here I have 2 to the 3 times 1/4 would be 2 to the 3/4. I don't need the parentheses anymore. X to the 1/4. And y to the 7/4. Next, I can multiply 2 to a power times 2 to a power by adding the exponents. 2/4 plus 3/4 is 5/4. So I have 2 to the 5/4. That takes care of the 2's. x times x, add those powers, 2/4 plus 1/4, I get x to the 3/4. And the y times the y, 2/4 plus 7/4, I get 9/4. And now I can think of this as 2 to the, I'm using the numerators, 2 to the 5th, x to the 3rd, y to the 9th, all to the 1/4 power, which in turn becomes 4th root of 2 to the 5th, x to the 3rd, y to the 9th. This is a pretty good 9 out of 10 points answer if it ever was a question on a test. But notice the power here and the power here is greater than the index, so we want to simplify this. I want to rewrite the 2 to the 5th so that I get the biggest possible divisible by 4 exponent like we did in an earlier lesson. The x to the 3rd is okay because it's less than the index. Its exponent is less than the index. And the y to the 9th, I'm going to rewrite that. 4th root y to the 8th, 4th root y. And this will change, and this will not change, this will not change, this will change. This becomes 2 to the 4 divided by 4 is 1, just a plain old 2. And this becomes y to the 8 divided by 4 is 2. And we still have these 3 pieces to put under that 4th root radical sign. A 2, x to the 3rd, y. There's the final answer. That's a doozy, huh? Okay. Thank you for your patience. That's the end of page 6. One more page after this.